All right, here's the 10.1 homework video key. And what I want us to do when asked to find areas in between curves, first of all, understand that the area is always positive. Greater than 0 means you're positive. And probably what you first thought when finding the area between R and H is that you could find the area under R and then subtract the area under H. Okay. And either by using integral properties or preferably by drawing a rectangle and thinking about an integral as being an infinite sum. I want you to now think of taking an infinite sum of these areas of these rectangles. Now the area is a rectangle, so the area is a height times a width. The width is a small change in x. So I'm going to sum up a bunch of these from A to B, A being an x value, B being an x value. And I got my widths. But my heights, well, this height is this y coordinate minus this y coordinate. That'll give me this distance right here. So the y coordinates will change based on where my x coordinates. So I want the top function with respect to x to give me the y minus the bottom function with respect to x will give me a y coordinate. So top minus bottom will give me this y distance in between. So we want to now think of this. It'll make things a little bit easier if we were to evaluate things by hand and we don't have to write two integrals out. So this is what we want to kind of focus our efforts on, is this top minus bottom as the height times the width. With the width being a small change in x. Okay. I want to find the areas of R1, R2, R3. I'm just going to write the integrals, but not simplify. So let's look at R1. So I'm going to draw a rectangle in R1 and realize the height of my rectangle is going to be 1 minus this curve. Now, let's see. We are told that this is y equals the square root of x, and this is y equals x squared. So the height there would be 1 minus root x. And I'm going from 0 to 1. R2, here's a rectangle for R2. The heights will be root x minus x squared from 0 to 1. That's my heights times my width of my rectangle, infinite sum of those. R3. My heights are going to be the x squared minus 0. I don't have to write the minus 0, but just maybe if you want to, if you feel comfortable with the top minus bottom always, you can do that. Then we get that. Okay. Now we're going to talk about this value, x equals k, that splits this region into two equal parts. Well, to do this, let's first find what the total area is. I could do this by hand. I got 1/3 x cubed is the antiderivative. We don't forget about that. Taking the antiderivative, I get the area is 1/3. Well, the area from 0 to the line, let's just call this line x equals k, has to be 1/2 the total area. So I'm going to say the area from 0 to k of x squared must equal 1/2 my total area, which I found was 1/3. Okay, well, what do I do now? We can evaluate this integral, and we can use k. Now, it's very important just to go one step at a time. We'll take the antiderivative. I have x's when I take the antiderivative. My boundaries are 0 and k. And then I plug in k and I plug in 0, making sure like I plug in both of these values. I have 1/3 k cubed minus 1/3 0 cubed. Okay, well, the minus 1/3 is gone. I want to make sure you plug this in, though. so that you know that if it was something other than 0, you get a number here. And this equals 1/2 my total area, or 1/6. Well, now I have an equation to solve. 1/3 k cubed equals 1/6. I'll multiply both sides by 3. I get k cubed equals 1/2. I'll take the cubed root, or the 1/3 power, and I get 1/2 to the 1/3. And what's great, and what we're going to want to do just while we're doing this the first time around, is kind of check our answers and use our calculator. So I think from 0 to the cubed root of 1/2 of x squared, I think that's going to be 1/6. That's 1/6. And that is half of the area from 0 to 1 under x squared, which is 1/3. Okay? So we were able to do that now. Like, the answer was not nice. You know, it's a weird answer, 1/2 to the 1/3, but that's correct. It's going to be a little bit bigger than a half, because you can visually see that, you know, you're not going to go halfway between to split this area equally. All right, but now we talk about intersecting graphs. If you can intersect multiple times or just twice, and you're asked to write an expression with that, with an absolute value and without. Great thing about absolute values is that no matter what you plug into an absolute value, you're ending up with a positive value. So no matter if you plug in f first or g first, when you subtract the two, you'll either get a positive or a negative, but the absolute value make it a positive. That'll make this a positive height. And then you multiply by your width. So you can go all the way from A to C, and you'll have negative heights and then positive heights, but the absolute value will make it positive. Now what I want us to do is be able to split this into two integrals to realize from A to B, to get the correct positive height, you're going to have to do g of x minus f of x being this function here. So g is over f, so this is the positive height. This will give me the positive area. Area is always positive between curves. It's kind of back to being what area, area to be. But then I have to add the area from B to C, and in this case, f is now the top, and g is the bottom. Okay, so this would be two different ways to find the same area. This way you can do with a calculator no matter what. If you're given a question and you had a calculator, man, just use this for any situation. If you didn't have a calculator, you're forced to split it up. If we intersect in more than one locations, now I didn't give you any boundaries, so let's just like throw some values in here, like A, B, C. That's my bad. But here, either with a calculator, we can go from 0 to C. It doesn't matter, f minus g, g minus f, whatever, doesn't matter, because the absolute value will make all the heights positive. Or, no calculator, we're going to have to split it into multiple integrals. We'll have to go from 0 to A. The top is the f function. And then from A to B, the top is the g function. I'm not going to bother putting in the x's, you kind of understand. And then from B to C, the top is back to being the f function. Whoops. Okay. All right, now we're going to do some stuff without a calculator. We're going to find the area enclosed by x squared minus 5 and y equals negative 4x. The best way to start this off is to figure out our boundaries. Like, where do these two graphs intersect? I like to find the intersection first, and then I'm going to sketch the graph so I understand the top and the bottom. To find the intersection, we're figuring out when do our y's equal for given x's. So we set the equations equal to each other. Now when I solve this quadratic, I need to move everything onto one side and factor. Get x plus 5, x minus 1. So I have intersections at -5 and 1. So now I'm going to go ahead and sketch. So I'm going to focus my attention on -5 and 1. And x squared minus 5, we know, is a parabola, something like this. And we could kind of plug in values, like if I plugged in -5 into this, I'd get 25 minus 5, which is 20, and -4 times. So this is all the way up here at 20. Doesn't really matter, the y coordinate, as long as the x coordinates are correct. And I know y equals 4x is definitely going to be above this parabola that's opening upward. If we kind of know how the parabola is opening, and this intersection is going to be at 1, -4. I don't really care about that. But now we can at least see the area that we're talking about. Let me just kind of fill it in so you can see it, and then draw a representative rectangle. So here's my rectangle. I'm going to be summing up the areas of these rectangles. So I'm taking an infinite sum of the areas starting from the next value of -5, going to an x value of 1. The heights are a top minus the bottom. The top in this case is -4x. The bottom is x squared minus 5. Now notice I'm putting this in parentheses because I'm subtracting the entire function. And that's going to be with respect to x. Maybe I want to rewrite this a little bit. I have -x squared minus 4x plus 5. And now I need to find this area without a calculator. It's going to be a little bit messy, but that's what asked of us to do. Like a -1/3 x cubed is the antiderivative, -2x squared, and 5x plus c. We don't need it because we're going to be plugging in values and subtracting. A little bit of messy work, but here we go. -1/3 1 minus 2 plus 5. That is going to be the antiderivative at 1. Minus the antiderivative at -5. 5 cubed is 125. So I have positive 125 thirds, because the -1/3 and the -125. And I have 25 times 2, so that's going to be -50, and then -25. Okay, so I'm going to do a little bit of legwork here. Actually, yeah, let's just do a little bit of legwork. I got -1/3 plus 3. And then I got -125 thirds minus 75. Add an opposite, I'll get -126 thirds plus 78. Might as well do this. 78 times 3, 4, 20, 21, 22, 23, 234 thirds. -126 thirds plus 234 thirds. 234, 126, subtract 8, 0, 108 thirds. That does divide evenly. Not the square root of 3. 36. Check your answer using a calculator. Gladly. Watch. You want to make sure you're doing things correctly. -5 to 1. Use an absolute value. -4x minus. Make sure you're using a quantity. X squared minus 5. You could have done it in opposite order. And there's your answer. 36. Boom. Check. Another one without a calculator. Find the area enclosed by y equals x and y equals x squared minus 3x plus 3. Okay, so again, find the intersection. Get 1x squared, subtract an x, so that's minus 4x plus 3. It's going to be x minus 3, x minus 1, so 3 and 1. So I'm going to sketch focusing my attention on 1 and 3. They intersect at 1, 1 and 3, 3. Y equals x is a straight line. The x squared, I'm not exactly sure what it'll look like, but you know, maybe something like this. There's my area. So again, the line is on top of the quadratic. This will not always be the case. If the quadratic was opening downward, then we're talking about the quadratic being on top of the line. Take an infinite sum from 1 to 3 of the top minus the bottom. So that's the top minus the entire bottom. Do a little bit of simplification. I got a negative x squared. X minus negative 3x, that'll be positive 4x. This is why we kind of do this at once so that we can simplify. Take the antiderivative, negative 1/3 x cubed plus 2x squared minus 3x from 1 to 3, and do a little bit of legwork. We get 27 divided by negative 3, so that's negative 9. I have 9 times 2, that's 18. I have negative 3 times 3, that's negative 9, so that's going to be 0. And I'm going to subtract 1, so subtract negative 1/3 plus 2 minus 3. That's good. So this is 0. This is negative 1. Okay, good. So this is negative 1/3 minus 1. So that's negative 4/3. So subtracting negative 4/3 will give me a positive 4/3. And like, let's check that with a calculator. Watch again, I could go, and as long as I use an absolute value, you can do either minus the other. Maybe I want to put the x squared first. X squared minus 3x plus 3 minus the x, like you don't need to use parentheses there, and I'm going to get the same answer, 4/3. Okay. All right, with a calc, find the area of the enclosed function. So either 2x and 4x plus 1, you can graph now. You can literally see what things look like. So I got e to the 2x, I've got 4x plus 1. Okay, so you can't really see, but we see the little bit of area right here in between things. Okay, now the important part here is to be able to graph and understand their intersections. Can't really find the intersections by hand. In this case, I'm going to have to find the intersection using a calculator. So this first intersection, it looks going to be at 0, 1. Sorry, second to calc, intersect, enter. Yeah, 0, 1. Maybe if your calculator gave you, like maybe if you were a little bit to the right of things, it wouldn't give you exactly 0. Yeah, 6.774 times 10 to the negative 15th. We should know that that's your calculator telling you it's very, very close to 0. E, negative 15, that's times 10 to the negative 15th. That's 14 zeros after a decimal, followed by 0.677. You have to know that this is your calculator telling you that this first intersection is at 0. Second intersection, up here, is at this weird decimal, 0.6282156. I have to use the entire decimal because I'm not going to simplify my answer till the end. So I'm taking an infinite sum of these rectangles, starting at 0 and going to 0.6282156 of the top minus bottom. The top is the line. It's not always going to be the line. I hope we understand that. We have to really see things. Divided by the function. Go back into your home screen, type it in. 4x plus 1 minus, you don't need parentheses because it's just this one thing, e to the 2x. And I get the area is 0.161. Sine of 2x and y equals x. Let's see what that looks like. I got sine 2x. My calculator's in radian mode. I got x. Okay, so since I have my calculator, and I notice there's multiple intersections, I got something like that, and something like this. I can see I got this area here and this area here. I'm going to find both of these intersections here and here. I'm going to use an absolute value. Second calc, find my intersection. Enter, enter, enter. So its first intersection's at negative 0.947747. The second intersection, I think, is going to be at the positive one, right? Yep. Now, what we can assume, it's probably safe after seeing things visually, is that this times 2 equals the total. So I'll show you. We could either, let's use an absolute value, go from negative 0.947747 to positive 0.9477471 of absolute value 1 minus the other, or I bet you if you go from 0 to 0.9477471 of the top minus the bottom, that's the sine 2x minus the x, that you're going to get this if you multiply it by 2. So let's see. Negative 0.9477471 to 0.9477471 of absolute value sine 2x minus x. I get 0.420 or 0.421. And then I bet you if I take twice the area from 0 to 0.9477471 of top minus bottom, I get the same answer. Okay, so cool. Find the line that line x equals k that splits the 3 previous areas into 2 equal regions with the calculator. Well, this third one is easy. Third one I can see x equals 0. Okay, because the right side and the left side equal areas. X equals 0 is going to split the region into 2 equal parts. So to the left is the same to the right. But I want to just focus on the area in the first quadrant, and we're going to do the problem just with the area in the first quadrant. Let's do this top left one. So in this situation, an area from 1 to k of the top minus the bottom, and I've already done the top minus bottom. It's negative x squared plus 4x minus 3. That'll equal 1/2 the total area, so that would be equal to 1/2 of 4/3. Okay, now I've already taken the antiderivative, so it's like we're doing the same process again. It's an x cubed. That's a 2x squared. It's equal to 2/3. And then I plug in k, and then subtract 1 plugged in. And that needs to equal 2/3. Yikes, I don't want to solve that. Don't worry, this is the easy part. If we set it up, now we can solve using our calculator. And we'll go back and solve that using our calculator. So we get y equals the left side and y equals the right side, and we can find the intersection. This is how you can solve any equation. I'm not even simplifying anything. Right side, 2/3. The intersection that I'm looking for has to be between 1 and 3. So I see there's an intersection here, but I'm not looking for that intersection. I'm looking for this intersection between 1 and 3. So that's this one. There's 3 intersections, but I'm looking for the one that's got to be in my interval from 1 to 3. That's going to be at 2, which is pretty incredible, but yeah, look at that. It actually is the midpoint. Won't be for the next one. So for the next one, this is the one on the top. Here's the bottom left. The line is going to go from 0 to k of 4x plus 1 minus e to the 2x. And that has to equal 1/2 my area. I'm going to go back and in my calculator have that entire area listed. So 1/2, like 0.16109400867. And that's the number. Okay, but then the next procedure is, to take the antiderivative of this left side to plug in k and plug in 0. So I got 2x squared plus x minus the antiderivative of e to the 2x. We need to remember is 1/2 e to the 2x. It's the antiderivative. Then I subtract. When I plug in 0, I get 0, but I have minus 1/2 e to the 0. E to the 0 is 1, so I have this minus 1/2, and then that's equal to that value 0.080547043. I will graph to solve this crazy equation, but our calculator will help us. 2x squared plus x minus 1/2 last room on the left. If it's locked, I'll give you a key. Yep. 1/2 e to the 2x minus, it ends up being plus 1/2. That's the left side. The right side is 0.080547043. Graph. This intersection right here between 0 and 1, second calc, intersect that one, 0.330. I forgot. I'm sorry if I screwed you up here. This is going to be from 0 to k, and then you have 2k squared plus k minus 1/2 e to the 2k, then minus 0 plus 0 minus 1/2. And that gives me 0.330. So that's what k is equal to. Okay, so that's close to being halfway from 0 to 0.628. And then for this one, I'm just going to focus on the first quadrant. So 0 to k of sine 2x minus x has to equal 1/2 my area. So that's 1/2 that 0.420 number. Take the antiderivative. I have negative cosine 2k times 1/2. Derivative cosine is negative sign, so I need a negative. Need the 1/2 because of the 2x. I have minus 1/2 x squared from 0 to k. This is another good one because when I plug in k, good. 1/2 cosine 2k minus 1/2 k squared. But when I plug in 0, cosine of 0 is 1, so this is going to be negative 1/2 minus 0. And that's going to equal, I'm going to pull up my home screen, pull up that value, divide it by 2, 0.210398947 and then I'm going to find the intersection using my calculator. .210398947. Graph, we're looking for something between 0 and 0.9. That's, I think I made a mistake somewhere. That's the area. Negative 1/2 cosine 2x, that's the correct antiderivative. 1/2 x squared, that's the correct antiderivative. Plug in k. Plug in 0. Cosine of 0 is 1. So it's minus negative 1/2. Up. I have to take this number. This number is actually this area. It's half of the overall area. So it's, I need to actually find a quarter of things. That was my mistake. So this is like that. I hope you understand why. Because I found the area of both of these regions, but I'm only focusing on this region, which means this region is half of this area, and then half of that is going to be half of my area. So I got to divide this by 2, and now I'm going to find the area. It's going to be right there, 0.501, so a little bit more than halfway. Okay. All right, now we're going to do some the free response problems that we've seen in past years. There's a bunch of them, but you'll see they're not bad. Some are no calculator, some are calculator. So we got part A, find the equation of the line tangent to f at x equals 1/2. This is a nice little review problem. All right, equation, you need a point and a slope. The point comes from f of 1/2. That's 8 times 1/2 cubed. That's 8 times 1/8, which is 1. So I have 1/2, 1. And then slope. Where does the tangent slope come from? Gosh, I could probably get asked you this question. Half of you would not get this right. Tangent slope comes from a derivative. And I'd plug in 1/2 into that. 1/4 times 4, which is 6. So my slope is 6. Sine of y minus y1 equals m times x minus x1. How many of you would be able to get that? Hopefully more than less. All right, find the area. I see 0. I see it intersects at x equals 1/2. They give me that. That's very nice of them to do that. So 0 to 1/2 of the top minus the bottom. How do I know which one's the top minus the bottom? You got to know that x cubed is this graph, and then the sine is going to be that graph. So you got to be able to figure that out. So I got sine pi x minus 8x cubed. You have to do this without a calculator. So let's go ahead and take the antiderivative. We'll have negative 1 over pi cosine pi x minus, this is going to be x to the 4th times 2, plus c. You don't need it because you are subtracting. I plug in a half, I get negative 1 over pi cosine pi over 2. That's gone. Minus 1/2 to the 4th. 2, 4, 8, 16 is 1/16, which is 1/8. Minus the cosine of 0 is 1, so that's a negative 1 over pi. Let's throw it in there. And then minus 0. So this is gone. I have negative 1/8 plus 1 over pi. And you can check that and plug this in and plug this into your calculator just for fun to check it. And you'd see it's the exact same area. All right, we got 2 root x and the horizontal line y equals 6. Find the area R. Okay, look at this. Here's my representative rectangle. The height of this rectangle is the top minus the bottom. The top is the y equals 6. The bottom is the 2 root x. The width is the dx. So I'll take an infinite sum from 0 to the x coordinate of 9. It's very important to understand that's an x, that's a y, of top minus bottom. And I need to do this without a calculator, so let's go ahead and practice. I got 6x minus x to the 3/2 times 2/3, so that's 4/3. From 0 to 9, I have 54 minus 9 to the 3/2, that's the square root of 9, which is 3. 3 cubed is 27. 27 divided by 3 is 9. 9 times 4 is 36 minus 0. So this ends up being a nice number. This is 18. Okay, and you can check that. $18. Remember, our calculator approximates. That's what it does. All right. Another one. You can see the intersections at 2, 4. So from 0 to 2, I'm summing up these rectangles. The height of this rectangle is going to be the line minus the curve. So that's my top minus the bottom. My width is dx. Probably should have been doing this from the get-go. Got 0 to 2 of height. It's a y minus a y. Y is a version of x's. Y as a function of x's. And that's going to be x squared minus 1/3 x cubed. From 0 to 2, I got 4 minus 8/3 minus 0. So 12/3 minus 8/3, which is 4/3. I feel like I already did that one. All right, with the calculator. All right, what's great about this one is it gives you the intersections. Wants you to find the sum of areas of regions R and S. Man, you know what's great? Our friend, the absolute value. 0 to 2, absolute value. You don't even have to write the full function. You don't even have to know which function's on the top and the bottom, because the absolute value will make sure that all of these these heights are going to be, so f minus g, this height. I don't know if that's right, but boom, that's going to be correct. This will save you a lot of time if you use this absolute value. So when you have a calculator, use your calculator and use it wisely. Math 9, 0 to 2. Thankfully, they gave you the intersection and you didn't have to spend time finding it. Now, why am I using 2 and not 4? Because we're talking about an infinite sum of these, all the way to the x value 2, starting from the x value of 0. All right, 0, 2, math, abs, either minus the other. Which one do you want to subtract from which? Doesn't matter. 1 plus x plus e to the x squared minus 2x minus x to the 4th minus 6.5 x squared plus 6x plus 2. This is in parentheses. You're subtracting the entire value. Dx. Boom. 2.004. And you know that's the sum of regions R plus S. You don't have to split it up. There's no need to split it up. The absolute value will take care of it. Oh, that's a good one. This is part B is very important. I think your test question is going to be similar to this. All right, find the area of R. Again, we can assume that they intersect at 2. I probably should check. I'm going to, but like they're really helping you out here, and not always will you be able to see the intersection so easily. Sometimes you'll have to find it, but they're making it easy for you. All right. Yeah, it looks like it's 2. I mean, 2 pi and 8 minus 8. Yeah, so it's definitely 2. I mean, sine of 2 pi is 0. If I plug in 2, I got 8 minus 8. So yeah, it's definitely that. So part A, since I have a calculator, if I don't really want to think at all, I could use the absolute value of either minus the other, but I can just visually see what the top and what the bottom is. So I might as well just like show that you know what you're doing. Math 9, 0 to 2, sine pi x. Please make sure your calculator is in radian mode. Minus x cubed minus 4x. Oops. Hope I didn't do that for any others. Four. That's nice. All right, part B. The horizontal line y equals -2. Here's the y equals -2. Splits the region into 2 parts. Obviously not 2 parts, 2 equal parts, right? But do not evaluate an integral expression for the area of the part R that is below the horizontal line. So we want this area here that's below the horizontal line. Well, look at that. There's my represented rectangle. If I sum them up, I'd be able to find that. Okay, now height is going to be the top minus the bottom. Great. So I'm most of the way there. But here's the problem. It's not from 0 to 2 anymore. This is wrong. Notice I have an intersection right here, and this is where I would start. And then an intersection right here, and this is where I'd end. I don't know those values, so this is when we break out our friend the graph, and we graph y equals -2. I don't need the sign graph anymore. There's that area that they're showing us, zoom standard just to see it. They're right there. Find those intersections. 0.5391889. I'm not sure if you can have these rounded, because I guess it is our final answer. So these values can be rounded, but I don't know. I'm just going to be careful, and this is fine. And then second calc, my other intersection over there, 1.675130. 1.675. I forgot that number. 1.607. 1309. All right, that's it. Find the area of R, find the area of S. Do you have a calculator? Fantastic. Here's the problem. I don't have the intersection. I can use my absolute value. That's great. Don't have the intersection, so I'm going to have to do a little bit of work here. Let me pause first. All right. So in my calculator, we'll graph the two equations, 1/4 plus sine pi x. We'll graph 4 to the negative x. I can see there and there. Probably zoom in if you want to. There's that first intersection. 0.178218. The second intersection, second calc intersect. 1. That's nice. Okay, area of R. Integral from 0 to 0.178218 of top minus bottom, or use an absolute value. The 4 to the negative x is this, minus 1/4 plus sine pi x. I'm not going to bother plugging that into the calculator. So, and then for B, S would be from 0.178218 to 1 of top minus bottom is now the sine. And that's what I get. Vertical line, x equals k, divides the regions into 2 equal area, right? But do not solve an equation that involves integral expressions whose solution gives a value k. Watch how I can do this without having to plug in anything into my calculator. Here's x equals k. Oh, I have to plug something into my calculator. I have to figure out what this intersection is. But watch. Oh, then I asked you to find the value by solving. Okay, never mind. Well, let's go. Let's try and do this quickly. X to the 4th minus 2.3 x cubed. Oh. Plus 4. Y equals 4. Graph. Standard. There it is. First intersection is at 0, 0, 4, and then the second intersection. It's at 2.3. That's nice. All right, so this is 2.3. Let's find the area. 0 to 2.3 of top minus the bottom. Get that area. If I were to do part C without having to find the value, I would have done this. 0 to k of the top minus the bottom equals either 1/2 this or k to 2.3 of that. And that's also something I could have done. But let's go ahead and find this value. So antiderivative is going to be, I'm going to go back to the first one. It's going to be 4x. Oh, the 4's cancel. So the 4's cancel. I just have negative x to the 4th, so that's negative 1/5 x to the 5th minus 2.3 over 4x to the 4th. The 4's are gone. From 0 to k will equal 1/2 to 3.218 value. So plugging in k and plugging in 0, I do just get this minus 0 equals 1/2 of that. Let's solve. Oops. Negative 1/5 k to the 5th. Minus 2.3 k to the 4th equals 1/2. What was that value? Let's just store this as a. And then you could do 1/2 that value of a. I made a mistake. Oh, what did I do? 4 minus 4 is 0. That's going to be a negative. That's going to be a positive. Oh, that's a positive. Bloop, bloop. Bloop. All right. Second calc, somewhere between 0 and 2.3. 0.934. How many more? 2, 3, 3. Find the area. All right, we have to find the intersections. I'm not going to show you. I mean, we've done enough. Find this intersection A using your calculator. Find this intersection B using your calculator. It's going to be from A to B. Those are x values of the top minus the bottom. That's log x minus 2. Okay? I'm not going to bother. I have to go to a meeting. This, pretty easy. I see the intersections are at 0 and 2. So from 0 to 2, top minus the bottom. The cosine graph is on the top. This is G. This is F. So G minus F. Done. 0 to 1, easy. 0 to 1, top minus the bottom. If the functions are like shown to you like this, like F is equal to that and G is equal to that, you can just write this and get you a numerical answer. That's it. All right, so those last things were easy. Hope we understand this. Things will get more complicated next class when we start talking about doing things with horizontal rectangles. So be ready for that. The key is this. The key is that you have to draw your rectangle so you see what it looks like. So height here. I think it's freezing. It's really slow. Hope this is being recorded. It's not like slow motion. Like, look at that. What's going on? Can't even move my mouse. Oh, please don't like freeze and die. I'm just going to save. Height is R minus H. Okay, I'm gonna stop this recording and hope that this key saves, or I'm gonna be upset. Okay, good. There you go. My height is top minus bottom. That's it. Thanks.